Every year, 25 million tourists pour into a city that is actively disappearing beneath their feet. Venice continues to subside at about 1 to 2 millimeters per year, while relative sea level in the lagoon rises at roughly 3 to 5 millimeters per year on average, accelerating recently.
Behind me, the tide is rising again. They expect to have a new high tide, this time around 130 centimeters.
Venice is no stranger to floods. Billions have been spent on a project to improve the city's flood defences since 2013.
Do the maths, and you realize the Adriatic is gaining on Venice at 4 to 7 millimeters every single year in some periods. That might not sound like much. Give it a century under continued high-emission trends, and you're looking at nearly 3/4 of a meter of relative sea level rise on top of what's already happened. In November 2019, Venice experienced its worst flooding in over 50 years. The waters surged to 187 centimeters above normal levels, swallowing piazzas, invading basilicas, and destroying businesses in a matter of hours. Residents waded through chest-deep saltwater in the dark. And the multi-billion euro system designed to stop exactly this? It sat on the seabed, unfinished, years behind schedule, and tainted by one of Italy's most brazen corruption scandals. This is the story of MOSE, a 6 billion euro flood barrier that took over 20 years to build, was nearly killed by a 21 million euro bribery ring, and now faces a problem its designers never fully anticipated. It's working, but it might be working too much. You see, Venice doesn't sit beside the sea in the traditional sense. It sits inside a lagoon, a shallow body of water separated from the Adriatic Sea by a series of narrow barrier islands. 3 inlets, Lido, Malamocca, and Chioggia, act as gateways between the open ocean and the lagoon. When the tide rises, water rushes through these 3 openings and floods the lagoon basin. When conditions align, southerly winds from the Adriatic, known as the Scirocco, push enormous volumes of water toward the coast, and that water has only 3 places to go. The result is acqua alta, literally high water, and it's been plaguing Venice for centuries. But here's what's changed. The frequency of tides exceeding 110 centimeters has increased dramatically, from a few per decade historically to dozens in recent decades. The trend is accelerating. Venice's problem isn't just rising seas. The city itself is sinking. Built on millions of wooden piles driven into soft sediment, Venice has been subsiding for centuries. Industrial groundwater extraction in the 20th century made it dramatically worse. The pumping was eventually stopped, but the damage was done. The city dropped by roughly 25 centimeters over the last 100 years. Combine that with Adriatic sea level rise, and you have a city caught in a vice, squeezed from above and below simultaneously. By the early 1980s, the Italian government recognized that something radical had to be done. That something would become one of the most expensive, controversial, and technically audacious flood defense systems ever attempted. MOSE, which stands for Modulo Sperimentale Elettromeccanico, was conceived in the 1980s and formally approved in 2003. The concept was elegant in principle. Engineers would install rows of hollow steel gates across all 3 inlets connecting the Adriatic to the Venetian lagoon, 78 gates in total. When tides were normal, the gates would lie flat on the seabed, completely invisible, allowing ships, tidal flows, and marine life to pass freely. When dangerous tides were forecast, compressed air would be pumped into the hollow gates, forcing out the water inside them and causing them to rise like hinged flaps until they formed a continuous wall across each inlet. But turning that concept into reality required construction on an almost absurd scale, much of it underwater. The first challenge was building the foundations. Each gate needed to be hinged to a massive concrete housing structure sitting on the lagoon floor. These housings, essentially enormous concrete caissons, had to be fabricated, transported, and sunk into precise positions on the seabed. Workers dredged and leveled the inlet floors, then placed the caissons into prepared trenches. Each one had to be aligned to millimeter tolerances, because the gates needed to form a continuous, watertight barrier when raised. At the Lido Inlet alone, the channel was so wide it required 2 separate barrier rows with an artificial island built between them to anchor the system. That island didn't exist before MOSE. Engineers constructed it from scratch in the middle of the lagoon, creating a new landmass to serve as a hinge point between the northern and southern gate arrays. The gates themselves are steel box structures, each one between 20 and 30 meters wide, roughly 20 meters tall, and up to 5 meters thick. They weigh approximately 300 tons each. When resting on the seabed, they sit inside their concrete housings and are filled with water, holding them flat. To activate them, compressed air is fed through pipes running from onshore plant rooms, displacing the water and causing the gates to pivot upward on their hinges. It takes about 30 minutes to raise the full barrier system. Now, everything about this process had to function in an extraordinarily corrosive environment. Salt water, constant tidal movement, biological fouling from barnacles and algae, and the sheer pressure of the Adriatic bearing down on the structures. The hinges connecting the gates to their housings are permanently submerged, and after years underwater, engineers have already observed corrosion on several of them, raising serious questions about long-term durability. The final gate was laid on January 30th, 2019, 16 years after construction began. The original completion target had been 2011. The original budget had been roughly 1.5 to 1.9 billion euros. By the time MOSE was anywhere near operational, costs had ballooned past 6.2 billion euros, making it one of the most expensive flood defense systems in human history. And that brings us to the scandal that nearly sank the whole project. In 2014, Italian authorities dropped a bombshell. Venice's mayor, Giorgio Orsoni, was arrested alongside approximately 30 other officials and business people in a sweeping corruption investigation centered on MOSE. Prosecutors alleged a web of bribery, fake subcontracting, and systematically inflated contracts stretching back years. The numbers were staggering. Over 21 million euros in assets were eventually confiscated. Investigators uncovered 22 million euros in bribes and so-called gifts funneled between the consortium building MOSE and the politicians overseeing it. Contracts were padded, subcontractors were invented on paper, and public money was siphoned off at virtually every level.
Giorgio Orsoni was one of 30 people accused of financing election campaigns with bribes of 25 million euros from the group building the city's flood barriers.
For Venetians, it was a gut punch. While their city flooded, while billions were supposedly being spent to protect it, a significant chunk of that money was lining pockets. The scandal became a symbol of everything wrong with Italian megaproject governance, a cautionary tale about what happens when oversight fails on a project this large and this urgent. Construction slowed, public trust evaporated, and the Adriatic kept rising. On October 3, 2020, MOSE was activated for the first time in a real flood event. The barriers rose from the seabed and held. Venice stayed dry. It was, by any measure, a triumph. After decades of delays, billions in overruns, and a corruption scandal that threatened to kill the project entirely, the system worked. During those first 3 operational winters, the barriers were raised around 50 times, shielding Venice from the kind of devastating floods that had submerged it in 2019. Piazza San Marco, which had become a symbol of Venice's vulnerability with images of tourists wading through knee-deep water, stayed dry when MOSE was raised. Shopkeepers who had lost thousands in flood damage finally had protection. The engineering, for all its troubled history, delivered. But here's where the story takes a turn that MOSE's original designers may not have fully anticipated. The system was designed for exceptional events, rare extreme tides that might threaten the city a handful of times per year. It was never intended to be raised constantly. And yet, that's exactly what's happening. Since going live in October 2020, MOSE has been activated dozens of times annually in recent years. In its early years, it was raised perhaps 5 times annually. but the frequency of activations has shattered every assumption about how often this system would need to operate. Each activation costs roughly 200,000 euros to the Venice port community alone, and the economic toll of frequent closures continues to mount. The warning from experts is blunt. Under high-emission scenarios, within 30 years, MOSE may need to be activated daily. Now, think about what that means. A system with permanently submerged hinges already showing corrosion. Maintenance costs that have ballooned from initial projections of 10 million euros per year to 100 million euros. And under high-emissions climate scenarios, researchers project MOSE could be active up to 260 days per year by the end of the century. A flood barrier designed for emergencies is becoming a permanent wall. And this is where MOSE's success becomes its biggest problem. Every time the barriers rise, the 3 inlets between the Adriatic and the lagoon slam shut. That stops the flooding, yes, but it also stops the tidal flushing that the entire lagoon ecosystem depends on. A 2024 study from the University of Padua found that MOSE closures are already limiting the flooding of salt marshes, which are critical habitats ringing the lagoon. These marshes rely on regular tidal inundation to deposit sediment, and that sediment is what allows the marshes to grow vertically and keep pace with rising seas. Cut off that sediment supply and the marshes drown anyway, just more slowly. Water renewal times inside the lagoon have already increased, exceeding 11 days in some sections. Stagnant water means reduced oxygen, algal blooms, and degrading conditions for the fish, shellfish, and bird populations that depend on a healthy lagoon. Winter closures cause less biological damage because marine activity is lower, but as closures creep into warmer months, the ecological costs will multiply. Each closure also disrupts shipping traffic and port operations. Venice remains a working port, and every barrier activation halts vessel movement through the inlets. As closures become more frequent, the economic ripple effects compound. So what comes next? Some researchers have proposed something that sounds almost absurd: physically lifting Venice. The concept, floated by Italian scientists, involves injecting seawater into deep aquifers beneath the city to cause the ground to swell, effectively raising Venice by approximately 30 centimeters. The researchers argue this could buy the city 20 to 30 years of breathing space, time to develop more permanent, adaptable solutions. It hasn't been attempted. The risks are enormous. Uneven lifting could crack foundations, damage the very buildings it's trying to protect, and destabilize the sediment Venice already sits so precariously upon. But the fact that serious scientists are discussing it tells you everything about the desperation underlying Venice's situation. MOSE bought time. Nobody disputes that. The 2019 flood would have been significantly less devastating had the barriers been operational. The early winters of activation proved the engineering works, but a flood barrier designed for a handful of annual emergencies is now grinding toward daily use, and the city it protects continues to sink while the sea continues to rise. Venice exists in this strange twilight. The most visited city in Italy, a UNESCO World Heritage Site, a place that generates billions in tourism revenue, is also one of the most vulnerable inhabited places on Earth. MOSE was supposed to be the answer, and for a time, it looked like it might be. But the maths hasn't changed. Several millimeters of relative sea level rise per year, hinges corroding underwater, maintenance budget swelling by a factor of 10, an ecosystem being slowly strangled every time the gates go up. And under high-emission scenarios, a climate trajectory that could demand those gates stay up more days than not. The 6 billion euros question isn't whether MOSE works. It does. The question is whether a system designed for a 20th century problem can survive a 21st century reality. Whether the most expensive flood defense ever built is a bridge to a more permanent solution, or simply a very costly way of delaying the inevitable. More than 40 years after MOSE was first conceived, through corruption and scandal, engineering triumph and ecological consequence, Venice remains locked in a race it cannot afford to lose. The barriers rise, the water retreats, and for another day, the city survives. But the tide is patient, and it always comes back. Thanks for watching Hard Hat Industries, your source for the massive engineering and heavy iron shaping our world. If you appreciate the scale and technical complexity of these builds, hit like, subscribe, and turn on notifications so you never miss a breakthrough.